So thank you for joining this demo presentation. You can let's do it in an interactive way. So you can also put questions in the chat, but I think it's better if you just interrupt Manolis and ask him directly or at the end of the demo. So Manolis will manage this demo. So we are recording this demo. These recordings will be available in the YouTube channel of Open Science Fair and also in the website. Use the hashtag OSFAIR2021 if you want to make some noise about this demo. So yesterday we had the first demo of this tool. Manolis Terrovitis is in charge of this demo and responsible by this tool, and we have now the second round of demos. So Manolis, the floor is yours. So let's proceed with your presentation. I know that Manolis will run a short presentation and then a demo of the tool.
Thanks a lot, Pedro. Yes, I will run a short presentation, even shorter than yesterday. And okay, a few words. I'm Manolis Terrovitis. I'm a researcher in Research Center ATHENA. I work on, my background is data management, and I work in data anonymization for quite a few years. And we have developed the Amnesia tool, which I'm going to demonstrate here, which is an open source data anonymization tool available through OpenAIRE that you can use freely to anonymize your data. So I'm going to start with, okay, I have here the last picture, the last demo. I'm going to start with a few words on what data anonymization is, so that you get the context to understand what Amnesia does. I will go directly in the distinction between two terms that we hear often in privacy protection, anonymization and pseudo-anonymization, as they are defined in GDPR. Now, when in everyday language, when we talk about anonymizing a data set or an anonymous data set, what we usually mean is a pseudo-anonymous data set and a pseudo-anonymization in the legal terms of GDPR. What is pseudo-anonymization? Pseudo-anonymization is the removal of identifiers from a data set. So you have a catalog about, let's say if you have a data set with medical data and you delete the names of the patients and their social security numbers, then you get a pseudo-anonymized data set. The idea, this is called pseudo-anonymized because in pseudo-anonymized data sets, we usually have a way to reverse this anonymization. Now, this can probably be done through secondary bits of information, which are, the date of birth, the zip code, the hospital that someone was admitted. So the GDPR says that if you pseudo-anonymize something, and the result is a data set where there are no direct identifiers, but there is a way to reverse this anonymization, then this data remains personal data and not anonymous data. On the other hand, really anonymous data are data that have been transformed in a way that this transformation is irreversible and we can never go back to identify a person or attribute some property with great certainty to it. So the key idea here is that we do have some kind of guarantee in anonymized data sets, some kind of statistical guarantees that the anonymization transformation is irreversible. And that's what an Amnesia does. It transforms the data irreversibly with respect to some commonly accepted guarantee. Now, a question is why to anonymize? And the idea is that if you anonymize, you do a truly irreversible transformation of your data, then your data are no longer personal. You can use them without the constraints of GDPR. And you actually do protect the privacy of your users independently of your GDPR, because you do have a statistical guarantee for not identifying them in the data set. So this is the most suitable way to give data for research, right? To give it to wider audiences and not to worry very much about how it's going to be used, since it's no longer personal. Now, there are some obvious limitations that we're going to try to overcome or actually balance in Amnesia. And the basic limitation, which is quite obvious, but it has to be emphasized, is there is some kind of information loss. When you transform the personal data to anonymous with statistical data, then you lose some accuracy in the information. How much accuracy on what fields of your records? These are questions that they always get different answers depending on the data and the analysis you want to do. And Amnesia offers many different ways to balance this. If you look deeply into the anonymization processes, there are gray boundaries between pseudo-anonymization and complete anonymization. Actually, the Commission acknowledges that. There is a very interesting work on an essay from the working group on Article 29 that deals with that. We are not going to get deep on this, but I'm just going to highlight one or two weaknesses on the anonymization guarantees. And a final problem is that there's not enough experience yet. It's not an everyday process, so we cannot fully automate it. There is some kind of exploration, and Amnesia comes there and gives you the visual tools to do this exploration and decide what's the best solution for its case. So a few words on the guarantee that we're going to the statistical guarantee that's used in Amnesia. Actually, it's one of the guarantees that Amnesia offers, the simplest one, but I want to give you an example. Imagine that we have this pseudo-anonymized data set. This is a very simplified data set of a medical record where the names and the social security numbers have been removed. And what's left is the zip code, the age of the patient, her or his nationality, and the diagnosis. So although this looks anonymous in the everyday sense, it's pseudo-anonymous because anyone who knows the age of a person and the region where they live can probably identify them from this data set. If I know that Ivan is Russian and he's 28 years old, then I know he has a heart disease. So these secondary bits of information that can lead to the re-identification, we call them quasi-identifiers. And the data transformation happens on these fields that have to be first recognized by the one doing the anonymization. So what k-anonymity will do is it will transform the values of these fields. So it creates groups of k indistinguishable entities. So if I know that Ivan is Russian and he's 20 years old, then I can place him here in the first cluster, but I don't know which of these 4 records is his, so I don't know if he has heart disease or viral infection. And this is for anonymity. Now, I told you about the weaknesses. Each statistical guarantees has a different one. Here, if you have small groups, you are in danger of homogeneity attacks. For example, if I know that Jane is American and she's 31, then I can place her in this cluster. I don't know which of these 4 is her record, but I know for certain that she suffers from cancer. So the statistical guarantee holds, it's an irreversible transformation, but some privacy is leaked. And the only completely secure way to do it is not to publish anything. Then for each case, you make a risk estimation and choose the best parameters and the best guarantee for each case. Now, one more detail before we go to the demo is that, as you saw, we removed information from the quasi-identifiers. We actually generalized its original value and presented it in a greater granularity level. For example, instead of giving the exact age, we gave an age category, less than 30, 30 to 40, more than 40. Now, in order for the algorithm to do this correctly, it has to have some information because this is semantical knowledge. So this information is provided to the algorithm by the user in the form of a generalization hierarchy. The generalization hierarchy is actually a set of rules where you show in iterative steps how each specific value can be generalized more and more. For example, if this is this hierarchy for the age of a person, then what you actually instruct here the algorithm is that if the exact age is too accurate to appear in the anonymized data set, then try to present the decade where she or he were born. And if that's not enough, just remove the age. And of course, you can have a lot more steps that have have smaller steps in generalizing something that gives the algorithm better flexibility on how to do that. So I will go to Amnesia now and show how you can do all this stuff on the actual tool. Okay, this is the first page of Amnesia. You start from here. You can choose a data set from your local computer. For this demo, I'm going to use our latest feature, which is loading a data set directly from Dataverse. We already support Zenodo. Now we support also Dataverse. Now, in order to get a file from Dataverse, you have to provide the URL of the Dataverse server. You have to provide the API token that's connected to your account. This is the API token of our demo account. And then it has a thing that's called dataset persistent ID. You can basically consider it as an ID of a folder that has files with data inside. It's one of your own folders and you get its ID and you put it here. So if we give this information, then Amnesia will go to Dataverse, will read the directory and bring you back the files. Now I have the original file with data to be anonymized, and I have the anonymization result from the previous demo here. And of course, I'm going to choose the original data. And now the data is, we have started the loading process in Amnesia. Now, Amnesia accepts text files that are delimited. So in the simplest case, where we have a relational table that is, an Excel-like table with a fixed number of columns, we only have to provide a delimiter that defines its columns. So in this case, it's the Greek question mark, and voila. Amnesia has read the file, it has splitted the columns, and it has guessed the data type of its column. Now, this is only a guess. Amnesia has read the first few values of the data and has decided that this is a string, this is an integer, and so on. This has to be confirmed or corrected by the user because Amnesia has only read the first few files, and it's also a kind of semantic decision if we want to treat the NHS number like a number or like a string. In this case, the data types are okay for the example. And the second thing we have to do is decide which of the columns will actually participate in the result. And obviously the NHS number and the name of the patient should not be in the result. Now, by removing these three columns, I create a pseudo-anonymized data set, right? The no direct identifiers. You do have the this is again a data set. It's a synthetic data set that resembles simplified medical records from UK hospitals. So these are the diagnosis codes on ICD-10 and ICD-9 codes, which is a global accepted ontology about diagnosis. And as descriptive data, we have the date of birth and the marital status. So I remove the rest and I leave this data, and these two, I believe they act like quasi identifiers. So I load the data set, it has this form, and now I have to provide generalization hierarchies in order for Amnesia to anonymize the quasi-identifiers. For the marital status, I have created in the past a hierarchy. It is stored like a text file. The text file can be edited by hand, or you can create it in a visual way. In a visual way, you don't get the hassle of the format, but it's a bit slower to create its node and then save it. So this shows that these original answers, which are the kind of answers that people give to the question married, and they say no, divorced, widowed. So I group these to single, and then if single and married cannot appear because they give too much information in the data, they just have to be removed. So this is the generalization hierarchy for the marital status. Now, Amnesia can help you auto-generate a hierarchy from the values of a single field. This works bestly on numerical data where you have a total order and you can actually create ranges, and you have smaller and greater, and these things work. For example, if you consider the example with the age that we looked into in the presentation, we could tell Amnesia that, you know, create ranges of decades for its age, and then group decades together in groups of 3 till you reach just one node. So I'm going to show you how you do this in the most complicated case of a continuous domain, which are the dates. Now, the dates are complicated because we do not measure dates with a decimal system. We measure them with a strange system where we have 7-day weeks, and we have 12-month years, and 10 years. Okay, they are in the metric system. So the best thing to create a hierarchy is to choose the field that's going to be used as a basis for creating the hierarchy and give a hierarchy name. Now, Amnesia has read the data, it has decided which is the smallest value that appears and the greatest value that appears, and it decides that this is the domain size. I can change it or I can accept it as it is. Then I have to define in the steps where the initial domain is going to be split in terms of days, months, and years. So I want Amnesia to create groups of 7 days, of 3 months, and of 3 years. And from then on, it should group every 3 nodes together till it reaches just a single root. And this creates a hierarchy like this. Now, the original, this is 7-day ranges to group the original birth dates, which in their term, they are grouped to 3-month ranges, and these 3-month ranges are grouped to 3-year ranges. And from now on, every 3 nodes are grouped together. Okay, 2 because we don't have enough here. Every 3 nodes are grouped together till we reach 1 node that represents the whole domain. Now we have created the rules that the algorithm Amnesia will use to anonymize the data. So we can go to the anonymization algorithm. We choose the k parameter. I will put a very small k here, which is actually the smallest k that you can put and have some kind of anonymity, which is 2. Each combination of values from for the date of birth and marital status will appear at least 2 times. And I instruct Amnesia use this hierarchy that we just created for the date of birth, for the date of birth field, use the marriage hierarchy for the marital status, and the diagnosis codes cannot be used as quasi-identifiers. So I am not giving them any. I'm not associating them with any kind of generalization hierarchy. So I'll say execute, and Amnesia has actually given us a complicated lattice instead of a single solution. So what is this lattice? As I told you in the presentation, a key question always is how much information we're going to lose. And it's not only how much, but it's also the question of where are we going to make the biggest sacrifices, which are the data we want to preserve best. So here, Amnesia had impact on two attributes, the date of birth and the marital status. Now, depending on the field, on our analysis, on our perceptions, this might not be equally important for making for data analysis. So Amnesia will give us now all the combinations of different anonymization levels for these two fields, and its combination is represented by a different node. For example, this node says that I have generalized the date of birth 3 times. So one time it became a 7-day period, 2 times a 3-month period, and then a 3-year period. So here dates are represented as 3-year periods, and the marital status have been generalized just once, so it's single or married. And these are all different levels. Now, if the node is blue, it means that the privacy guarantee that we want, the true anonymity, is preserved. If it's red, then it means that it's not preserved. Obviously, we should be mostly interested on the nodes that are blue, and they are the lower level ones. But sometimes even those that do not, okay, not this, I think this is better. Even the nodes that do not provide us with the desired guarantee do so only because very few of the records violated it. Here it's 3.4% of the records that violate the guarantee. The other cases that might be 0.3%. So in some cases, it's better to delete the records that violate the guarantee and keep the rest as they are in order to avoid generalizing more of the data. So I did here this thing, and I get this final result. So the diagnosis code are not used as a squash identifier, so they are identical. The date of birth from an exact date, it's now presented as a 3-year period. The marital status is preserved as originally. There is a guarantee that each combination of date of birth and marital status in the output data will appear at least 2 times. So if I know information about a single person, I will always find 2 candidates here. And the records that are marked as red will be deleted from the result. And so the resulting data set will have 3.4 less records than the original in this case. And this is done. Now we have the anonymized data, and we can save them locally to the node or to Dataverse, wherever we want. So this concludes my presentation. There are, of course, other features that you can look into it. More complicated guarantees like KM anonymity. Amnesia can be used independently of its front end. You can get the data anonymization engine and fit it to your own information system through a REST API. But okay, I keep for the demo the most simple and complete example. So please, if you have any questions or you want me to clarify anything, please let me know.
Thank you, Manolis. I don't know if people have questions, so you are here. It's because you are interested. We are coming to the end in terms of time, but I think it will be good. I don't know if people. So Alan is already asking the question here in the chat. So, but everyone feel free to turn on your microphone and then ask the question. So Alan Alikas is asking here: is there any plans on implementing high diversity to offset the dangers of using key anonymity?
Yes. Hi, Alan. This is a good question. We do have a plan to ultimately add L diversity, but in our current roadmap, we plan to add differential privacy before L-diversity, since it has become more popular, although actually L-diversity is a simpler extension for key anonymity. So you are going to get first a differentially private mechanism that will be able to do that, and it will be after maybe in this year, but not in the next 4 months for L-diversity. Differential privacy has a different, completely different concept, but it addresses that this problem of homogeneity attacks too.
Great. Do you want to highlight, if people don't have more questions, do you want to highlight some use cases that you are aware of, those that are using Amnesia tool in different scenarios, and that they are asking your support? Can you share some 2 or 3 examples of those use cases in order to make it clear for the participants here?
Okay, one simple and one of the last use cases that we have been asked to support is about treating of questionnaires about discrimination in academia. There's a project where they do explore discrimination, mostly based on gender in academia. So they get detailed questionnaires for different universities, and now, since it's a consortium, they have to share the data between themselves or make it publicly available that other researchers and analysts can analyze or just verify the results. And in this process, they want to use Amnesia to anonymize the results of the questions before sharing them openly. And I think this is a very characteristic case.
May I ask you a question? So,
sure.
Thank you. This has been really interesting. I would like to know if do we have a personal area where we keep the first data set and the second one, so we can see what we have done to guarantee the anonymization?
Yes, about personal area. The key idea in Amnesia is that we have created as a standalone application. So you download it to your own laptop or your own premises, and you do the anonymization locally. So you have everything on your own computer. We do have an online version, which is for demo and training purposes. But the safest way to do it is use it locally, or if you trust enough your Dataverse server or Zenodo area, you can do it there, again in your own account and your own folder. But the safest thing is to do it locally. You don't even need an internet connection for everything to work. You have it in your hard disk and everything works, and you can do the comparison and whatever you need.
Thank you.
Samuel Simango is also asking about if there is any support.
Yes, we have a help desk that gives generics.
Maybe you can share the link, or you can open the website if you.
Yes, I will. Let me open the website.
In fact, in amnesia.openair.eu,
yes, it's here, and you go to contact, and you can use the form, or you can directly send questions to Amnesia help desk at athenarc.gr. So this is free support. For just installing the dataset, you won't need just installing the application. You won't need anything more than that. It's a simple jar file. If you have Java, you download it and it runs in supported platforms. So it's quite simple. If you want support with additional features or for complicated data set, then we have a paid service for this kind of thing. But to get support to install or simple questions, then we have the help. We have the help desk, and that's all you will need.
Samuel also want to check if the tool can be installed in a local.
It can be installed in personal computer. Installation does not require anything more than you can have the Java runtime environment installed in your computer, and it runs in most Linux distributions and in Windows. Okay, thank you for the recommendation about the GitHub repository. So yes, I will look into it so we can have the community to be able to contribute.
Great. So we started 5 minutes late due to the other lightning talks, but so we have already ensured 30 minutes. So Giovanni is asking about the requirements for the installation.
Yes, I'm writing. And requirements are here. When you download it, you can see which versions are available.
Okay, so people really interested in the service, maybe asking questions. So Manolis, maybe you can also share the link here. So the link node. So I can also put it here for the. If people want to ask you a question, of course, you can share your email address, but also this email address that I'm having here in the chat is the one that you can contact to request support. So I think it's good to share it.
Yes.
Okay, I think we are done. Do you want to do any final remark?
I would like to thank everyone for being here, and please feel free to send me any questions or any problems you have with Amnesia, and I'll be happy to help.
Okay. Thank you very much, Manolis, for the contribution to the Open Science Fair conference, and all the participants. Thank you for the interest and for being here with us. So in half an hour, in fact, we continue the program of the Open Science Fair. In half an hour, no, in 1 hour, sorry, in 1 hour, or in 50 minutes to be in 50 minutes with a keynote, turning point in research assessment on the road to open science. So if you are interested, please join the plenary session in 1 hour. Okay. Bye-bye all. Thank you very much.
Bye-bye. Thank you.